laminar flow. In the laminar flow, we have the first one is Reynolds number. What is the Reynolds number? It is the ratio of inertia force to the viscous force. The formula is rho Vd by mu. Here V is velocity or average velocity. D is length of the pipe, not diameter, it is the length. Mu is dynamic viscosity. According to the Reynolds number, we can classify the flows, that is in the pipes and in open channel flow. So if the Reynolds number is less than or equal to 2000 in the pipes, then it is laminar flow. In the open channel flow, if the Reynolds number is less than or equal to 500, then it is also laminar flow in the open channel flow. Okay. If the Reynolds number is between the 2000 to 4000, then it is transition flow. It is for pipes. If the Reynolds number between the 500 to 1000, then it is transition flow for the open channel flow in the open channel. Next one is turbulent flow. If the Reynolds number is greater than 4000, then it is turbulent flow in the pipes. If it is greater than 1000, then it is also turbulent flow in the open channel flow. So the entrance length required to establish fully developed laminar flow is given by LE by D equal to 0.07 into Reynolds number. Here D is diameter, entrance length will be given in the question. It is for the laminar. For the turbulent, entrance length by D equal to 50. For the pipes we have the which type of flow in the pipes, that is the laminar flow. The shear stress distribution is given by, this is shear stress, it is 0 at the middle and maximum at the extreme fibers. See, your maximum at the extreme fibers. So shear stress is dou P by dou X into R by 2. Here negative indicates the decrease in pressure. See, shear stress is directly proportional to R radius. Okay, shear stress is directly proportional to R. Maximum shear stress equal to 8 mu V by D. Here V equal to average velocity. Equation valid for the steady and uniform flow. This equation, shear stress equation, is valid for the steady and uniform flow only. Okay, now it is not valid for the other type of flows. So velocity distribution. The velocity distribution is parabolic. Shear stress distribution is linear. It is parabolic, it is linear. Okay, give maximum velocity is it will occur at the center. See, in the figure we can see here 1 by 4 mu into dou P by dou X into R square. Here negative P dou P by dou X is decrease in pressure. U equal to U max. This value we have that U max put here, and 1 minus small r square by capital R square. U mean or average velocity equal to U maximum by 2. What is the value you get here? U maximum value, that by 2. The point where the local velocity equal to mean velocity is given by small r equal to capital R by root 2. That value equal to 0.707 into R. Next one is pressure drop in a pipe. Pressure drop in a pipe is change in pressure, that is P1 minus P2 equal to 32 into mu V average into L by D square. Here L is length, D is diameter, V is average velocity. In the question, if we given velocity and length, then we have to use this formula. If the velocity is not given, if the discharge is given, then what we have to do? At the place of V, see, Q equal to A into V. So how can write V equal to Q by A? At the place of V, we have to put the Q by A, and if you solve, then we will get this formula. Here A is pi by 4 into D square. If you do the calculations, then we will get the 128 into mu into QL by pi D power 4. Okay, laminar flow between two fixed plates. Here total thickness, that is T. It is small element here. It is y direction. This z direction. Maximum velocity occurs is T square by 8 mu into dou P by dou X. Average velocity equal to this is for the fixed plates. Okay, average velocity equal to 0.66 into q max. In the examination he will give the u max value and then they ask you to calculate the what is the v average velocity. Then we have to use this formula. Discharge per unit width for the fixed plates. What is the discharge per unit width? See, q equal to 1 by 12 mu into minus dou p by dou x into t cube. Okay, this value will given, mu also given, t also given in the question. So the pressure drop in a given length p1 minus p2 equal to, this is for the plates, 12 into mu v l, 12 into mu into v into l by t square. T is total thickness of plate. Momentum correction factor, that is v equal to 1 by av square integration of v square into d. Kinetic energy correction factor alpha equal to 1 by a into v cube integration of v cube into d. Okay, laminar, for the laminar flow, for the turbulent flow, for the uniform flow, what is the kinetic energy correction factor and what is the momentum correction factor? Here kinetic energy correction factor alpha equal to, for the laminar flow it is 2, for the turbulent flow it is ranges from the 1.003 to 1.06. If it is range is not given, we have to select, if the given option is 1.03, then you can select this, or the value is ranges from the in between, that value you have to select. For the uniform flow, that is 1 and 1 for the same K and MCF. For the momentum correction factor, for the laminar flow, what is the value? 1.33. For the turbulent flow, it is ranges from the 1.01 to 1.12. For the uniform, this is same 1. Okay, so these what I am explaining, these are each and every question is previous IAS question, previous GATE questions, previous AEE, SSC, GE questions. Okay, and ISRO, WARC also, these direct questions are asked from this chapter. This, see here, moment correction factor, this is also previous question. A kinetic energy correction factor, this is also previous question. So if you see the previous year's question, definitely these questions are repeated questions. Okay, this is about the laminar flow.